Hi guys, so this is organic video 1. You need your new packet and you should definitely have a reference table by you. If you aren't looking at this, you're doing something wrong. So please get a reference table by you. Today's objectives, we're going to do the intro to organic. We're going to do naming. I'm going to introduce you to the homologous series and some prefixes. So we'll be using table P and Q. So at this point, please get out your reference tables to table P and Q. We're going to packet page 4 as well. So I want to start out, again, this is packet page 4, with what organic chemistry is. Well, organic, you might have heard things like when you're in the grocery store, food can be organic. Well, that technically means something different. For organic chemistry, it is the study of carbon and carbon compounds. So carbon is the first thing that should come to your mind when you say organic. Carbon's very special. Its atoms can form rings. They can form chains. Or they can form networks. That's pretty special. When I talk about a chain, I'm talking about they might bond like this, a chain of C's. And we'll learn that we would put H's on for those. We have imaginary H's there right now. And when I say rings, I mean literally they can form a ring. That would be a benzene ring. Really, at each of those corners, you would have carbon. So there would be a carbon here, carbon here, carbon here, carbon here, here, and here. And you would have hydrogens coming off of each of those. But this would be your ring. So it's kind of special. Not a lot of things can do that. So chains, rings, or networks. That will be important to know. And then we also want to know some characteristics of carbon compounds. But really, if you think of covalent compounds, you know a lot of these. So carbon is a nonmetal. So carbon compounds typically are going to have covalent bonding. Remember that molecular is the same as covalent bonding. Covalent bonds have very low melting points and boiling points, if we remember. They also have a special structure, carbons do. They have what's called a tetrahedron structure. That's when I put it in 3D. It'd be a tetrahedron. Tetra means 4. So if you remember long ago when we were talking and we built those models, carbon has that tetrahedral structure because if I had H's like this, tetra means 4, so it forms 4 points. And this bond angle is not, they're not 90-degree bonds, they're actually 109.5 degrees. And they're that way because it spreads itself out in that tetrahedral shape. Just write that. Tetrahedral shape. Generally, for number 4, we see the hint. It says it dissolves in nonpolar substances. So that means generally organic things will be nonpolar. I do use that word generally because they do have some polar bonds and things, but generally they're nonpolar. Typically, covalent things are very poor conductors. So that means organic things are poor conductors. And number 6, they react very slowly, which we should remember that as well, because we talked about ways to speed up a chemical reaction, and we knew that ionic was actually always faster than covalent. And carbon always wants, let's think of the tetra we had back up here, so it wants 4 bonds, which means it always wants to have those 8 electrons. So it will typically try to bond with, to have 4 bonds. Or it might do a double bond, it might do a triple bond, things like that. But generally it's going to try to have 4 bonds around it. So that's important to know. And now we move to our hydrocarbons. What is a hydrocarbon? Well, if I take both of those words, hydro, hydrogen, and carbon, so carbon, oops, I spelled that wrong. So hydrocarbon is just hydrogen and carbon. So you want to make sure that nothing else is going to be in that. So make sure it's just hydrogen and carbon when you talk about hydrocarbons. So we're going to talk about how to name hydrocarbons today. So it says, note, as we talk about hydrocarbons, pay attention to prefixes, which are going to be on reference table P, and suffixes, remember, that's the end of a word, on reference table Q. Prefix, your beginning. So pay attention to the beginning of the words and pay attention to the end. So I'm going to teach you about 3 types of carbon bonds, hydrocarbon bonds, and they include alkanes, alkenes, and alkynes. This is why I said it's important to listen to the video, because they will be spelled very similar and you say the words different. So we're going to start with our alkanes. Well, they're asking me for a general formula, so I should be looking at P and Q. Let's take a look. Here's table P. Now, table P has our prefixes, and we're going to use different prefixes than you are used to here. So I'll run through the prefixes. Meth means 1. F means 2. Prop means 3. But means 4. Pent is 5. Hex is 6. Hept is 7. Oct is 8. Non is 9. Dec is 10. I think the hardest ones are probably up here with the prop and but, because people want to say prop and but no, it's prop and but. And that tells me how many carbon atoms that I have. So we'll want to use those prefixes. You will want to get very familiar with table P. Table Q also really helps us here. This helps us look at our alkanes. So let's start our alkanes right here. The general formula for alkanes is this, you see CnH2n plus 2. Well, if we note down here, N is the number of carbon atoms. So basically what they're saying is that if you have your number of carbon atoms, you know your H's as well, if it's an alkane. So they give us an example. I can see my structural formula is when I draw it. And I can see that my structural formula here of ethane is right here. It has 2 C's and it has 6 H's. Well, that would also work with this formula. If I did Cn, so C2H, now it says 2n plus 2. So 2 times 2 is 4 plus 2 is 6. C2H6. That's what is drawn there. And notice that it ends in ane. This is going to be really important, that ane ending. Alkanes will always have an ane ending. Very important. So it says ethane for this. Again, 2 C's. So if you look back up, 2 meant F. So I have F. Oh, where'd that go? There it goes. So 2 means F. Ane means it has single bonds. If you take a look, these all have single bonds for my alkanes. So that's important. And the ending, ene. So let's go back here and write that down. So alkanes, your general formula. CnH2n plus 2. So again, ethane, 2 C's, ends in ane, single bonds. This is from your table Q. So I can put all single bonds around it. And I can put my H's on, that'll be there, and I know how many H's because we said C2H, plug into this formula. 2 times 2 is 4, plus 2 is 6, C2H6. So I gotta have 6 H's on it. You'll get used to it. Usually when you see a C, you just put some H's on. We know that it has the ane ending. They will always have single bonds. Always single bonds. And structural formula meant draw. Molecular formula meant to write the formula. So we know how to do that. We've already done that. New to us is this condensed formula. So a condensed formula is kind of like a mix between the two. So a mix of the structural formula and the molecular formula. So it is a mix of the structural and the molecular. So what I mean by that is you're going to basically shorten your structural, but I want to give more information than my molecular formula has. So my molecular just tells me I have 2 C's, but I don't know where they are. Well, if I look at my condensed formula, what I'm really going to do is I'm going to look at the carbons and tell them how many H's are on each one. So condensed, I look at this first C. The first C, I have a C, and I have 3 H's on it, so CH3. The next one I come to is another C with 3 H's, so CH3. That is the condensed formula for C2H6. I'm writing what I see. I could also write it like this. CH3, I have 2 of them. Both of them would be your condensed formulas. All alkanes, like we said before, have single bonds. They always will. And they are said to be saturated. Saturated. That will be really important. Very, very, very important. Single bonds are saturated. That means they're full. No other H's can jump on. Nobody else can jump on. They don't need anybody. They have enough electrons. Single bonds are saturated. Third time. Single bonds are saturated. Make sure you know that. Okay, so now we're moving on. We're going to do our alkenes. So let's take a look at our table Q. So my alkenes, the general formula, CnH2n. That means if I know my C's, then I just have 2 times that for my H's. So they give me the example of ethene, but notice ene. Alkenes will have an ene ending, E-N-E, ene. So if I were to write out the formula for ethene, I'd say F means 2, because I know my prefixes, so C2, H, well, 2 times 2 is 4. C2H4, we'll look right here, C2H4. Notice also right here, this is the important part, it has a double bond. Alkenes are going to have a double bond. Always, 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 they will have a double bond. It does not mean that they are all double bonds, but it does mean that they have some double bond. Okay, so our alkenes, our general formula, again, from table Q, is CnH2n. So if I do ethene, I can look at table Q if I want, but I know that F means 2, so I'll go to the molecular formula, C2. And I know that if it has the ene ending, then I use that. So H, 2 times 2 is 4. C2H4. So if I go to draw the structural formula, 2 C's, I have to have a double bond. And then remember that each C wants 4 bonds. So this first C over here already has 2. So I'll put 2 H's on that. This C has 2 bonds, so I'll give it another 2. And so now I have my structural formula. And then if I go to do my condensed formula now, just like before, I look at the first C. The first C has 2 H's on it. So the first C has 2 H's. The second C has 2 H's. So CH2, CH2, or you can write CH2 with a little subscript of 2. So we want to remember, which we're going to do it on the other side, but alkenes are going to have double bonds. Not all of them, but some will be double bonds. Double bonds. And alkenes will always have an ene ending. An ene ending. So we are actually flipping over to the very next page, page 5. So it says all alkenes have double bonds and are said to be unsaturated. Unsaturated. Okay, moving on to alkynes. Alkynes, let's go back. Let's look at our table Q. Alkynes have a YNE ending. Their general formula, CnH2n minus 2. And this example is ethine, YNE. And that is because I have a triple bond. A triple bond. So all alkynes are going to have a triple bond. They're not always going to have multiple triple bonds, but they will have a triple bond. So since they have that, I put that YNE ending. This says ethine, and that's because I have 2 C's. Eth means 2, ine means do a triple bond. So if I look, I have C2H2 as my formula. That is what it would be if I plug in. Try it right in there. Cn, your N is 2. So C2, now your H is 2N. So 2 times 2 is 4 minus 2. So I draw it just like this. All my C's continue to have 4 bonds all around them. So let's go. Write that down on, again, this is page 5 of our new packet. We can say alkynes, special with a YNE. General formula, CnH2n minus 2. It's always going to have a YNE ending. A YNE ending. They're always going to have triple bonds. And if I was doing ethine right now, again, I could look at my table P, or I'll go to my molecular formula. F means 2, so C2, H, 2 times 2 is 4, minus 2 is 2, C2H2. So I go over here, I would draw 2 C's. I know I have to have a triple bond, and then I have 2 H's to put on, so I'll put 2 off of, or no, wait, I lied to you. I have 2 total to put on, and that would make sense anyway, because I already have 3 bonds, so this C just needs 1, so I put 1 H here, 1 H here. So if I'm going to write the condensed formula, I want to think, okay, look at the first C. The first C had 1 H. The second C had another H. That's it. CH squared for this one. All alk, this shouldn't say anes, this should say alkynes. So all alkynes have triple bonds and are said to be, again, unsaturated. Unsaturated. That's really important. Alkenes and alkanes both are going to be unsaturated. Alkanes are saturated. So one more time. Alkanes are saturated, single bonds. Alkenes, unsaturated, double bonds. Alkynes, unsaturated, triple bonds. So just remember, before I move on to the next thing, when I look, I need to know my table P because I need to know my prefixes. If I see any of those prefixes, meth, eth, pro, but, pent, hex, hex, oct, non, dec, all of those are organic prefixes telling me how many carbons. If I know it has an ane ending, I know it's single bond, ene is double, ine is triple. So now what I want to do is a little bit of practice. So we're going to go to our packet page 10 first. So let's go to our packet page 10. And this is on alkenes. And what I want us to do is I want us to practice a little bit. So we have 1 carbon. Well, remember that alkanes, CnH2n plus 2. That's from table P. I know to use that formula. So if I have 1 C, C1, then I know my H's, I do 1 times 2 is 2, plus 2 is 4, CH4. If I go to draw the structural formula, I do 1 C. These would all be ane ending. Okay, so this would be meth, because meth means 1. Ane, because it's an alkane. So methane, single bonds. I need 4 H's, so I make my carbon happy with 4 H's. If I skip down and I do 3 carbons, well, C3H. Now I'm going to go 3 times 2 is 6, plus 2 is 8. C3H8. I can already name that. I know to say 3. I'm going to use prop. So prop. It's an alkane. So ane ending. If I go to draw that, I have 3 C's single bonded to each other because it ends in ane. And I'm going to put on 8 H's. Pretty much, if you go around to your carbons, you're just going to make sure that you fill them with H's. Double check. 3 C's. 1, 2, 3. 8 H's. 1, 2, 3, 4, 5, 6, 7, 8. So you're good. If I were to do 5 carbons, C5, H, let's figure it out. 5 times 2 is 10, plus 2 is 12. C5, H12. If I skip over and I do the name, I want to look on table P. I want to say, okay, what's 5? Here, I'll go back. I'll show you. What's 5? Oh, 5 is pent. So I go back and I say, okay, pent. Pent. And they're alkanes, so ane, so pentane. I'm going to put 5 C's, so 1, 2, 3, 4, 5. I'm going to put 12 H's. This C needs 3 of them, so 1, 2, 3. This needs 2 of them, 4, 5. Just keep going. C5H12. So I think that's good for my alkanes. So now I want to go, this is page 11. Now it is not possible for you to have an alkene that has 1 carbon. So I have that crossed out. So go ahead and cross off 1 carbon. That's gone. But I want to look on table P, see my formula. Alkenes are CN, H2N. So I'll just do a couple on here. Let's skip down to one we didn't. Let's do 4 carbons. So 4 carbons, C4, H. I have to figure out my H's. So 4 times 2 is 8, C4H8. If I want to name it, I go to table P. I look up 4. 4 is bute, so you got bute, and then ene, butene. That means you want to put 4 carbons. Now, you know that alkenes must have a double bond. That means I need to put a double bond somewhere. Unless you want to figure out how to put a double bond and name it just yet, I would just go with putting it on the front or the back, but go from the front or the back. So there is my double bond. I only have to have 1 for it to be an alkene. And now I got to put on my 8 H's. The first C already has 2 bonds, so it's going to get 2 H's. Doesn't matter how you put them on. The next C already has 1, 2, 3 bonds, so it's only going to need 1 H. The next one wants 2 of the H's. The last one wants 3. I'm making sure that each carbon has 4 bonds. Make sure that you have 8 H's. I do. So let's do, again, we're going to skip to one we haven't done. Let's do 6 carbons. 6 carbons. So C6, H12, because 2 times 6 is 12. I can go over here and I can name to say 6. I'm going to use hex. So hex, hexene. So draw 6 C's. Make one of them a double bond. And put on your H's. This one needs 2. This one needs 1. This one needs 2. This needs 2. 2. 3. Count them up. Make sure you got enough. Okay, let's try page 12. Alkynes. CN, H2N minus 2. Just like my alkenes, my alkynes are unsaturated. If I did one, let's do with 3 carbons. 3 carbons, I'd say C3H. Well, 3 times 2 is 6, minus 2 is 4, C3H4. Do 3 C's. I have to have a triple bond somewhere, so I'll make one of them a triple bond. So I would put my other H's on, let's see. This last C would need 3 of them. The next C over doesn't need any, but that C does. That is what, well, let's name it. To say 3 is prop. So propyne. So propyne would look just like that. Pick one of them to have a triple bond. Okay, I'll do one more. I'll do the one right after it. So 4 carbons, C4H6, because 4 times 2 is 8, minus 2 is 6. 3 fours, sorry, not 3 fours, 4 C's, I don't know what I'm talking about. 4 C's. One of them has to have a triple bond. I'll do the last one just to keep things interesting. But if you put it at the front or end, it's going to make your life easier. Before I put my H's, I'll go ahead and name it. I say 4 with but, and it's an alkyne, so butyne. I'm going to figure out what C's need a hydrogen. So here's 1. Here's 2 of them. Here's 3 of them. So 1, 2, 3, 4, 5, 6. I have a total of 6 hydrogens. I have a total of 4 hydrogens. And I am happy. Okay, so just about done here. So what I want you to do right now is do Packer page 10. I want you to finish it. I want you to fill them in with your drawings, those namings. Use table P, use table Q. Do page 11 and do page 12. Do all of those pages. Anything that we did not do in class, and just wait for the next video. Thanks, guys.